All right. Now, I told you in the last lab that there's a couple of important things in here that you wanted to keep your eye out, specifically for the lab 2, and that's going to be IP addresses. Because the first question on lab 2, well, the first question on lab 2 is going to be dumping the logs. So we can quickly go over that real quick. We'll just come back down here and do a quick help. We're going to go in here in my C drive and get rid of all these process files since we're actually, we don't have to because we have them all there. Darn. We're going to delete all those because we don't need them anymore. So in here, we're going to do, I know the first task requested is to download the log files for this lab. And I mean, that can be a very ambiguous request because there's obviously no log files in the activities folders that are just there for us to examine. So there's two ways you can do it. You can either load up the hard drive image that's in the activities folder into, I think it's a forensics imager or something like that. You can actually mount the hard drive onto your computer, and you can navigate to where those log files would be and go through them. Or you can try and dump them here in volatility as well, which is what I did. Now, I would not say to only do one or the other. I would say do both in order to ensure the logs are intact and make sense. Sorry. So here we can do the event logs. This will extract the Windows event logs and dump them to the file. Dump them to the area that you want them to go. So if you do evt logs, right? Did I do that right? Yeah, it's gonna say it needs a dump directory. So dump dot dir c, and when you hit enter, it's gonna do it. Now I've already done it because I was messing around with this the other night. It's gonna dump. Oh great, where'd it go? It's gonna dump these logs here: application events, security events, system events. Only the system events and application events have information in them, and you're going to see that several things happened. It's tough to read this because it doesn't really make sense, but you're going to see a lot of Warlock 6B 7AA4C as a machine name, I believe, connecting to our victim computer here, and that's very important data. That's something you'd want to highlight in your forensic report. Now here it doesn't really give you any other information like IP addresses unless I'm completely missing them, but that's alright. Alright, so there you go. In a nutshell, it says dump the logs. You've dumped the logs. I know some people are having not issues, but that was not easy, and that's because it doesn't really lay out what it's actually looking for. So we're going to go back to connections. Yeah, we're going to do connections. And we're going to see that 87.223.62.140. That's our local address here, right? So when we go into Wireshark, first things I'm going to ask you to do or get done is to first, you're going to want to, where is it? I know I'm like brain farting here. Could have sworn You're going to column preferences, right? So we're able to add and remove columns. One of the things I'm going to ask that you guys add is the TCP port number. So when you do, and that's just so you know what port that adversary computer, that intruder is trying to connect to. So that way it makes it easier for you to, how do I put it, segregate the traffic that's of importance. You're going to set up a custom field type and then type in TCP dot destination port, and then it will apply that and it will place it into your deal here. So you get TCP port here, right? The next thing that's a cool little thing is if you go to preferences and do name resolution, if you do resolve network IP addresses, instead of looking at just IP addresses, it's going to actually resolve the names that are associated with websites. See Dropbox. For me, this kind of helps because it allows you to pretty much push out what might be not interesting. Like, I mean, Dropbox is important because obviously our computer is connecting to it, which means it's probably sending something to there, and that's of interest in itself. But Dropbox obviously is not going to be the offending computer that's exploiting 87.223.62.140. So keep that in mind. Let's see. So the first thing is, what was the initial method used to conduct reconnaissance? Now when I look here, it's a lot of stuff, right? It's probably very, very mind-numbing what's in here. And believe me, Wireshark is it's not my favorite tool in the world. But we're going to come over here and we're going to say, these are the connections that were actually, when we looked at our PS list, 3904 was our bad PID. It was connected to the parent process ID that had no other PID, right? So we would know that 184.199.201.120 is probably not going to be doing something that we want it to do. So we come up here and we can run filters. So let's see, how do I do this? Type in the filter IP dot. We said it's 184, 199, 201.120, right? Oh, it didn't work. Believe me, I'm not at all how do I put it? I am not a power user on Wireshark whatsoever, so forgive me if I am a little rusty on here. This is interesting, but not what we want. If you open up the expressions, it actually lists everything out that's available for filtering with. I'll try this one. I think that's one I have in there. All right, here we go. That's why we weren't at the top, I think. Yeah. Forgive me. I feel like I'm doing something crazy and it's not really working to my... That one did not work, right? Oh, maybe that's why. Duh. Well, there you go. So you don't check your work. Okay, so we're back. So what I did in here was based on this PID, which is 3904, which we identified as a bad PID. I typed in this IP address here, 184.199.201.120, into a filter that's just going to show me the source IP is that. And what you'll see here, and this is the reason why I asked you guys to put that custom TCP port in, is you can actually see, as per the, what's the initial method used to conduct reconnaissance? Well, this guy here was using a port scan. You can see here he just walks down the ports, 1478, 1479, 1480, right? And we see that 1567 obviously works for him. If I'm not mistaken, hold on. No, it looks like he's continuing on to run that same port scan here. Synac. Keep walking down. We say he's still talking to our victim computer here. And you're going to see, here you go, 1598. So 1598 obviously is when it worked. And that time happened, let's see, I don't know if I have the time set up on here. We can probably add the network time on here when this took place. We'll do that. We'll see if we can do that real quick. We'll say that our initial intrusion happened at 22:21, 24 seconds, right? That's UTC, so what is that, like 5 or 6 hours back for Eastern time, right? I'm not sure what it asks for in terms of time, but it does ask for time. You know, just remember that this is universal time. So we see here it's connected to that port. It's got its acknowledgement and it has continuation data. Now these things here, they're not really going to tell you much. If you right click on these, you can do follow TCP stream and it's just going to give you, you know, the computers talking to each other. Actually, here you go. But most of it's going to be gibberish. Not of much use in our forensics analysis. You can go through them and see what's in there, but can't guarantee you're going to see anything. We see file manager and folder list. I mean, obviously this person's trying to do something, but it doesn't really give us a very good idea of what it's doing. So we'll close that. Interesting thing here is when you start seeing things like, where'd it go? I'm going the wrong way, of course. I say 22. Hey, what's going on here? Oh, Oh, sorry. I was wondering what in the world was going on here. Okay. Sorry, it was only following that particular TCP stream. So we got the handshake going on here. So continuation data is very important because this is where the fun stuff is going to be. This is probably a payload with something in it. So we do follow TCP stream, and you're going to see, there you go. This is what that particular thing was doing. So I was trying to connect to our computer and running different commands. So here you have a handful of questions answered. I think it says, where is it? Were any users added to the victim system? If so, list the users and correlate the network packets of this activity by listing the beginning packet number. So here you go, you see that in fact they tried to do a net user xadmin net local group add. They ran the task list in the command. There's that there, trying to kill the Chrome, task kill the Chrome.exe, probably when they're getting ready to end their exploitation and move on. Clearme.exe, this is likely for, what was that piece of spyware that we were looking at? And then adding a administrator account with a new password in order to create persistence on that machine. So that, and here it tells you everything. Clearme.exe was used. We have Chrome.exe. I mean, this deal right here pretty much answers the questions for Lab 2. We saw xadmin, we saw administrator, so this pretty much closes out, almost closes this out. There is a question about network traffic correlating to malicious activity. That's unreadable, and all we would probably do in that instance is do the source, come back over here and go back to IP source and actually put in the victim machine, and then do a TCP port looking at just port 443, and you can see all the different encrypted data going over the deal. Or you can filter it out using SSL or transport TLS, V1, V2, whatever. Okay, I'll just show that real quick. We'll do IP source 87.223.62.140. Type that in there, and look at this. You can see all that SSL data going. SSL data, obviously, too, that we are unable to read. Oh, never mind. I misspoke. I could have sworn last class we were really trying to find, I think maybe it was a different stream, or maybe it was packets that had nothing to do with the assignment, but as we were doing the forensics analysis, we found some other SSL packets that we just could not decrypt to save our lives. And obviously you can see here that we contain both keys in order to decrypt this SSL traffic, or it's possible that I added that myself before. Excuse me. Same thing. So let's see. I think I answered your question on malicious processes in the RAM that correlate to the network or log activity for sure. Potential concerns with log files. I think we kind of covered that in the discussions about importance of logs, but their potential vulnerabilities. Obviously, write that up. Is there any danger in relying on system logs for correlation of intrusion-based events? Once again, it's not that hard to access logs, specifically if they're not protected. You can't get that into them and erase them, but usually that's a telltale track that somebody was in your computer is if you go into the log file and there's absolutely nothing in there. As you saw in the log files that we have here, we have security event, internet, and system this one here that have nothing in them. Security event should at least have something in it, I would assume, but it does not. And then the last question, and it looks like the last three in this lab are basically knowledge-based questions. What would you do? What would be a possible method of safeguarding log files in the system? The other one here, like I was saying, is the evidence of time stomping, and that's where you're going to have to mount that hard drive and actually look at some of the files on the victim machine in order to see file creation dates, file modify dates, file access dates, all that good stuff, and that will give you a good indication of who was time stomping and who wasn't. Yeah, I hope this piece here helped you out. This was completely unscripted, as you could probably tell with the long pauses and my inability to talk sometimes. So I do hope that you found this informative, specifically regarding our questions about finding the initial method used to conduct reconnaissance, the time that the reconnaissance took place, the tools. I mean, I think we pretty much answered most of these. The tools that were used, network traffic, correlating, users added, and the malicious processes in the RAM, along with the other ones that are just knowledge-based, minus obviously the time stomping. So like I said, I hope this helps you guys, and if it does, let me know. If you want me to go over the FTK, I can download those tools onto my computer, and we can try to get that working as well. Yeah, just let me know in chat or in the Ask the Instructor section, and hopefully you find this well. Thanks.